Hello everyone. So in this video we'll discuss about the digital to analog converter, that is DAC. So digital to analog converter is a circuit which converts the digital signal to an analog signal. That is, if you give suppose this is a DAC circuit, okay, so the input will be in digital, that is either 0 and 1 form, and the output of this will be our analog signal. Okay, so this input is compared with some reference voltage. So mainly we'll make use of op-amp. Okay, so the op-amp will compare this digital input, so according to this digital input compared with the reference voltage, and then we will do get the analog signal at the output side. So there are basically two types of digital to analog converter. One is binary weighted resistors and second one is R to R resistor. So as the name itself is telling, binary weighted resistor here is the input will be binary form, that is either in zeros or 1 form. Okay, so this is digital to analog converter with binary weighted resistor. So this is the circuit of DAC with binary weighted resistor which make uses of op-amp in the inverting mode, that is the inputs are connected to an inverting mode and the non-inverting mode is connected to grounded. Okay, so this is nothing as which is acting as a summing amplifier. So here we are connected the 4 inputs, so 4 number of binary input, so that it is called 4-bit converter. So 4-bit digital to analog converter we can say. So here you can observe, so each binary input is connected with the resistor. So each binary input is connected, each switch, binary switch is connected to, one is ground, another one is 5 volts. So since we have a 4 inputs, so we can have 2 power 4, that is 16 combination of output. Okay, so so there are 4 inputs which is connected in the inverting mode with each resistor, with each switch is connected with the resistors. So first switch with R by 2, R by 4 and R by 8. So since switch R is connected to 10 kilo ohm, R by 2 is 5 kilo ohm, R by 4 is 2.5 kilo ohm and R by 8 is 1.25 kilo ohm. Okay, and the switch is connected to, the switch will be connected to, depending on the input, it is connected either to plus 5 volt or either to the ground. Okay, and there is a feedback resistance RF. Okay, suppose now, so we'll say when this switch B0 is closed, that is for the combination of 1 0 0, that is 0 0 0 1. So if this is B0, B1, B2, B3, suppose B0 switch is closed, that is connected to plus 5 volts and remaining switches are connected to ground. Okay, so now the path will be closed now, so it acts as a closed circuit now. So the voltage across resistance R will be 5 volts and the current through resistance R will be, and the current through R will be 5 volts divided by 10 volts is equal to 0.5 milliamps. Okay, so 0.5 milliamps. We know that, so input bias current of an op-amp is 0. Why? Because so since this is in the non-inverting terminal is grounded, so from the concept of virtual ground, VID is equal to 0. So IB is equal to 0. So whatever the current which comes here entirely flows through the resistance RF. So the output voltage V0 is now, V0 is equal to minus RF, since this is in the inverting mode, minus RF into I, that is RF is 1 kilo ohm. So therefore V0 is equal to minus 1 kilo ohm into 0.5 ohm, that will be minus 0.5 volt. So next, in the next case, when the switch B1 is closed, that is when the input, so this is 1 0 0 1 0, when the input is, this is for 1, this is for 2. This is 8421. Therefore totally 16 combination. So when switch B1 is closed, okay, so now the switch B1 is connected to plus 5 volts and remaining all the switches are grounded. So here R by 2 resistance, that is 5 kilo. So the voltage across R by 2 resistance is 5 volts. Therefore the current through the feedback resistance will be 1 milliohms. So the output voltage will be V0 is equal to minus 1 kilo ohm into 1 milliamp, that is will be minus 1 volt. So in case 3, when both switches B0 and B1 are closed, that is for 3. So this is 1, 2. So 0, 0, 1, 1 is 3. Okay. So when both the switches are closed, so the output will be minus 1.4. That is, it is act as a summing amplifier now. So when both, so output will be minus 1. So now, so taking these many combinations, so up to 16 combination, we keep on calculating what is V0. So depending on the switches from B0 to B3, either closed or binary weighted current will be set up in the input resistor. So binary weighted current will be set up by the input resistors. So this part will be acting as a summing amplifier when more than 2 switches are closed, and we can calculate the what is the output voltage as we have calculated now. Okay, now the sum of the current is equal to the current through RF. The sum of the current through the resistor will be the same as the current through RF, which is converted to proportional output voltage. Okay, now at finally when all the switches are closed, that is when all the switches are connected to plus 5 volt, the output voltage equation is given by V0 is equal to minus RF divided by B0 by R plus B0, B1 divided by R by 2, B2 divided by R by 4 plus B3 divided by R by 8. Okay, so this is the output voltage equation when all the switches are connected. So this is the graph of output versus input. So output is, so input is, this is 16 combination 0, 1, 2, that is 0, 0, this is 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, so up to 1, 1, 1, 1. Okay, so if you plot, so when 0, the output, when the all input are 0, the output voltage is 0. So when the input voltage is 1, that is 1, when the binary input is 1, so output will be minus 5 volt. When binary input is 2, the output will be minus 1 volt. When binary input is 3, so this is a steps which takes like this. So giving this to a filter circuit, that is probably, so with all the 16 combinations, so if this is op amp with all 16 combination, so output might be like this. Like this. Okay, so when we give this output to a filter, so the smooth output we will get. So this is the so this is about digital to analog converter. Thank you.